Okay folks, so in today's video we're going to be looking at curve sketching, which just follows on from the asymptote videos where we'll be using and investigating asymptotes of a curve, but then also wanting to find stationary points, determine the nature, and find all the crossings on the y-axis and the x-axis to sketch what the graph looks like properly. The method we're going to use, you can see it written down there, so again you can pause the video to write that down, but we're going to find the asymptotes first and investigate the approach. That'll be the stuff that's new to us this year, okay, that we've been practicing in the last two videos. Find the stationary points, determine the nature, which we do have a second way of doing, second derivative test that can help us there, if it's easy to get a second derivative. And then part C, we want to then find the crossings of all the y-axis and x-axis, again, if easily found. Okay, depending on the functions, that can be a lot trickier regarding certain values that we get. So just a wee quick note, the nature table may also be easier than finding the second derivative in order to determine the stationary points in nature. Okay, so again, we've got up our sleeve from last year. So let's start us off. We'll just do one example to show us the process. This is a long question, but we'll look at the first one here. So example one, we're going to be given the function, so we'll sketch the curve. Of f of x, which equals 2x squared plus x plus 1, all divided by x minus 1. Okay, so that's the question you could be asked. We want to sketch that curve, we want to find out what's happening here. Okay, now a lot of times at advanced higher you're going to get a fractional function because of that's where the asymptotes can occur a lot of times regarding the denominator. First thing we're going to do though, and it would be a better idea to have this because it will help us regarding asymptotes, which is our first step. Let's see if we can factorise the numerator to make it life a bit easier for ourselves, which we can do. It factorises to be x plus 1, 2x, minus 1. Oh, I've just actually noticed I've made a wee mistake there regarding my function. Sorry folks, just edit this. It should be 2x squared plus x minus 1 on the numerator. Okay, so it should be minus 1. So, if we factorise that, we get the two brackets on the top, two factors on the top, divided by x minus 1 there. Okay, so that will help us for a certain part of the question. So the first thing we're going to do is work out the asymptotes. Okay. And the first ones we'll look at are vertical asymptotes. Okay, that's the first video we've done regarding asymptotes. We'll look for the vertical one. We do that. Okay, so again, that's when we set the denominator equal to 0. Okay, to find out what that would be. So that would be when x minus 1 equals 0. And if we solve that, we get x equals 1. Okay, so I found my first vertical asymptote, my only vertical asymptote. In this case, x equals 1. Okay. Excuse me. So, my asymptote will look like that, x equals 1. We want to know what happens either side of this, okay? And this is why I've actually factorised it, because it's going to make it easier to work out what's going on here. So, as x approaches the value 1, but from the left side, okay, so coming from the negative side towards x equals 1, what happens to my function? Okay, so remember we're picking a value just before the value 1, okay, and I mean just before, so you're thinking about the value like x equals 0.9 for example, that would be the value you'd be thinking about when someone in the function here. What would happen to my function here? So we know it's going to be x plus 1, okay, and if my value is 0.9 for example, that first factor will be positive. My second factor, okay, well two lots of something like 0.9 minus 1 would still be something positive. The denominator, x minus 1, okay, well if x is 0.9, that would actually give me a negative denominator. Okay, so I'm just subbing into my factors, getting what sign each one would be. Therefore, overall my fraction would be negative, okay, because the negative denominator. Therefore, it's approaching negative infinity. Okay, so just before it gets to the value 1, my graph is down at negative infinity there. Okay. We'll now do the same regarding the other side. So as x now goes to 1 from the right hand side, okay, so you're picking a value something like 1.1, sub into your function, see what happens. So we're going to get a positive on both the numerator factors and also on the denominator factor. So therefore, as everything's positive, we've got a positive value for infinity, so it's shooting up just after the value x equals 1. Okay, so we found our first asymptote, we found the vertical one, we now know exactly where the graph is at that point. So that's the first thing achieved there. Okay, second thing we want to do is work out any non-vertical ones. Okay, so we're now looking at non-vertical. So remember, this could mean it could be a function that is a horizontal line. An asymptote-wise, it could be a line with a slope, y equals mx plus c of the form. Okay, so we've got to now think about how we can find that. So remember, first thing we do, long division. What the long division? So we're dividing by x minus 1, and the function was 2x squared plus x minus 1. Okay, so we're putting this into here. Okay, so the first thing I want to do is multiply it by 2x, that will cancel the 2x squared. So that's going to be me subtracting 2x squared minus 2x. Okay, so 2x squares cancel, x minus negative 2x will give me 3x there. And negative 1, subtracting off it, we'll still be left with negative 1. Okay, so that's the first step done. Second step, we can still keep going. I can cancel that power of x out because I can times everything by 3. So that's going to be 3x minus 3. That I'm going to be subtracting when I multiply x minus 1 by 3. And that's going to give me negative 1, take away negative 3, which would be positive 2. Okay, which would be left behind. I can't do anything more with that. So my function f of x, okay, it fitted in 2x plus 3 times. Okay, plus we had a remainder 2. And that was still getting divided by x minus 1. Okay, so we've got that there. Okay, what we do now is divide the fraction by highest power of x. Okay, so that's what we're going to do now. We're just divide our fraction by the highest power of x. Highest power of x is being just x in this case. So it'll still be 2x plus 3 plus 2 over x, all divided by 1 minus 1 over x. Okay, and the reason why we do that is because we want to put into infinity either side of the asymptote. We can then just focus on what our function would look like. Okay, so we've got that there. So as x goes to both positive and negative infinity, what does our asymptote actually look like? Well, our function f of x actually just becomes 2x plus 3. Okay, so that's what happens there, which means that we've got a line with a gradient of 2 going through the y-intercept at 3. Y equals 2x plus 3. Okay, so we've got a positive slope like that. So we've got a non-vertical asymptote, one with a gradient. We've found that there. Okay, what we want to know is what happens either to the left-hand side and the right-hand side. So let's start off with negative infinity. So as x goes to negative infinity, so I'm subbing negative infinity into my function here, we know that the fraction basically is 0. We just want to know what is the sign of everything here, because it's going to stay at 2x plus 3. But obviously if I put negative infinity as my numerator, the numerator is going to be very, very small, but it's still negative, so just below. Therefore, overall, the function goes to 2x plus 3, but from below. Okay, it's just slightly underneath it. Okay, that fraction is just going to take off something very, very small from it, so it's slightly underneath. Okay, so at the very start of this line, we're underneath, we're below, just slightly below 2x plus 3. As x goes to positive infinity though, Okay, what side does the function go to for the asymptote? Well, again, the numerator would be positive. The denominator, okay, is effectively just going to be 1, taking off something very, very small for it. So that's not going to change anything. So because the numerator is positive, it's going to add something very, very, very small to it. So it's going to get slightly bigger, ever so slightly, above the line. So we're over there. Okay, so that's what my two asymptotes for this function look like there. We've got the vertical one, we've got the non-vertical one. That's all the advanced higher stuff that we've been practicing just now there. Okay, so quite a lot there. So if you want to pause the video and take stock, feel free to do so. We'll now move on to look at, can we actually now get the stationary point? So this is now section, or part B in the method here. So, part B, stationary points. Okay, so, now this is where you've obviously got a few different versions of your function. You've got the function I gave you to start with. We've got the factorised function, which helped us with the asymptotes. Might not be as ideal for regarding the stationary points, that though, because it's harder to differentiate that. Or you've even got the long division way we wrote the f of x function, okay, which actually is a little bit easier when it comes to differentiating. So I'm going to write the f of x function the way it was when it was looking after long division. Okay, so that's what my function looked like with long division. So what would f dash x look like? Okay, so 2x become 2, 3 would disappear. This thing here would end up becoming negative 2 over x minus 1 squared. Okay, if you use the chain rule, if you brought that x minus 1 up to a power negative 1, done the chain rule, you'd end up with that as your function there. Okay, so stationary points occur. When f dash x equals 0, okay, that's for higher, we should know that. Always state it though, okay, always state it. So 2 minus 2 over x minus 1 squared, that equals 0, okay. Okay, so if I make it over there and bring it positive, it now looks like that there. I can divide everything by 2. And if I multiply both sides by x minus 1 squared, I'm left with that there. Okay, now solving that, if you multiplied out and solved it, just for quickness, very National 5 level question here. The two values you would get would be x equals 0 and x equals 2. Okay, they're the two values that you would need in order for that equation to work. Okay, put 0 in, it would become 1, put 2 in, you'd get 1 there. The only values that would work there. Alright, so we found our two x values. It was easier using the long division part of f of x to help us get that there. Right, so again, next stage, as done from higher, we'll now get what the values are of the y coordinates. We need that as well. Okay, so we're going to do the y coordinates. So at x equals 0, first of all. Right, okay, so again, you could use any of the functions that we've wrote down in any form, is what I mean. You can use any form if you want. I'm actually going to stick to the form that we had starting the stationary point, so the long division form. That might just make life a bit easier here. So it's going to be 2 lots of 0 plus 3 plus 2 over 0 minus 1. Okay, so there's something 0 there. Let's have a bit more space there. Okay, so what will that actually give me? That's going to give me 2 divided by negative 1, so be negative 2. That's just going to give me the value 1. Okay, so it's going to give me the coordinate 0, 1. When x is 2, that's going to be 2 lots of 2 plus 3 plus 2 divided by 2 minus 1. So 4 plus 3 is 7, plus 2 divided by 1, that'll be, which will be plus 2, that'll give me a value 9. I've got 2, 9, that's my second coordinate. Okay, so again, you could use any part of the f of x function to do that with you, okay, so sometimes one makes it a bit quicker than the others. Right, nature table, or nature I should say. I'm not going to use a nature table here because all I need to do is work out what f double dash of x is, okay, f prime prime of x. So remind yourself, f dash x, the function we got was 2 minus 2 over x minus 1 squared. That's what we got when we differentiate the first time. If I differentiate that, okay, the 2 will disappear, okay, and if you use the chain rule for the second part, you end up actually getting 4 over x minus 1 all cubed. Okay, so that's actually what the second derivative would be. That was pretty easy for me to work out, so that's why I chose that method. Okay, I could have done it without too much work there, so that's why I chose that method. Okay, now what we do, we're going to use that to get our values here. So we substitute in our x values here. So our first value was 0, so that's going to be 4 over 0 minus 1 all cubed. So that's going to be 4 divided by negative 1 cubed, which comes out to be negative 4. Doesn't really matter the value, the main thing is that it is less than 0. Therefore, 0 minus 1 has a maximum turning point. Okay, if the second derivative is less than 0, it's a maximum. Okay. Put in the second value. So, put in value 2, that's going to become 4 over 1 cubed, which again becomes 4, but again, we're not really interested in that. The most important thing is that it's positive, greater than 0, therefore, our second coordinate ends up being a minimum turning point. Okay, so in this example, okay, and again, this is where I've maybe paused the video to take stock, it's fairly easy for me to have done that process. Second derivative, sub the values in, work out if it's positive or negative, etc. If it's not, you've got your nature table from higher, that would have done the same trick, okay, getting the same maximum minimums out if you do that carefully. Okay, right, so the last thing you need to do is just work out what's happening regarding the axes. Okay, so at C, axis crosses. So let's start off with axis crossing, quite a bit better. Cuts axis. Okay, when y equals 0. Remember, y is just the same as f of x. So that means when f of x is 0. And again, you've got lots of different forms you can actually do this with. I actually think the best form to do this one with is actually the second form we wrote f of x down, which is the factorised form, not the long division form, but when we got the original function and we factorised it. Hopefully you'll see why in a second, why this makes it easier. But when we factorise the numerator, that's what our function looked like. Okay, we've got that there. Now, if I multiply both sides by x minus 1, what actually effectively happens here is that I end up just with the numerator equals 0. And that's actually quite important actually, because this function to equal 0, well, we've already checked the asymptote for the denominator to be 0, but we can't get a 0 in the bottom of a fraction, therefore it's only the numerator that could make this fraction 0. Okay, so that's actually why we get that there. Now, solving both of those factorised versions, and this is why it's better to have it factorised, as you can see that I'm going to get x equals negative 1 and x equals half there. That's where it's going to cross the x-axis at both those parts there. Okay. So, crossing the y-axis is when x equals 0. Again, you can use any type of function you want. You just need to sub x equals into your function here. Again, I would probably just use the factorised version here. So that's going to be 0 plus 1, 2 lots of 0 minus 1, divided by 0 minus 1. And if you work out like that through, so the first one's going to give you 1, second one's going to give you negative 1, so 1 times negative 1 would be negative 1. The denominator's negative 1. We get the value of 1. Okay, so we just get that there, which comes out to be the coordinate 0, 1, which is actually one we found. That's actually one of our stationary points. Okay, and that can be likely, okay, but we've noticed where it crosses the y-axis. Okay, always do that step though, because it sometimes can cross the y-axis in more than one place if a curve's bending back round and stuff like that. Okay, so this year you need to double check all your stuff. Right, so very long process. We've got all the information now. We've got our asymptotes. We've got the stationary points. We know their nature. We also know now where it crosses the x-axis and where it crosses the y-axis. So let's actually all now put this together into a lovely sketch. Now, apologies in advance because my sketching skills are not the greatest, but it is a sketch we're looking for. First thing to do, put your asymptotes on. First asymptote we found was at the value x equals 1. And you want to put it as a dotted line, okay, not a bold line, okay, because our graph's going to be a bold line, but we want to put it as a dotted line, or a dashed line I should say, because our function cannot cross there, okay, that's what we just discovered there. Our second one was y equals 2x plus 3. Now that means that it's at crossing the y-intercept at 3, and it's got a slope of 2, so therefore that's our two asymptotes there, ish, okay? But you get the idea. We've got a slope there, sort of curves a bit too much there, but we've got a slope line there. What to now do is put down what happens either side of the asymptote, which we found, okay? So for x equals 1, our first asymptote, so before it got there, the curve was down here. After it, the curve was shooting up over there, okay? So that's where the graph's going to have to be. For the y equals 2x plus 3 asymptote, okay, at negative infinity, it was underneath slightly, so it was underneath the asymptote, and all the way at positive infinity, it was above, okay? Now we'll put in, okay, our two stationary points. Now our two stationary points were the value 0, 1, and we had a maximum, okay? That was the one we had at a maximum. We had 2, 9, so at the value 2, okay, and 9, we had a minimum. So this is where my graph won't actually look properly at scale now, but that's where the minimum curve would actually be, okay? Minimum turning point there at 2, 9. So what's actually happening here is the graph's coming down, hitting that turning point, and it's then shooting off towards there. Okay, so that's what's happening at the top half there. What's happening at the bottom half, okay, it's starting off at negative infinity, it's then coming across, going to the turning point, having a maximum, and then coming back down. So that's where my two parts of my curve actually go. Now the only thing I haven't actually put on my graph is 2 points where it crosses the x-axis here, which we worked out the values to be. This value here was at the value x equals a half. This value here was at x equals negative 1. Okay, so you can see the graph's an awkward looking graph. When you've got lots of asymptotes, it's determining a lot of different stuff regarding the graph. All your job to do is sketch it though. I think what sketch means from higher, it means having a relevant shape to the graph, as relevant it can be, because it can be very awkward, but having all the data that you've collected, okay? So even though my graph isn't maybe the most aesthetically pleasing, as an artist maybe would say, it has a turning point, it has the values of the turning point, it's got the roots, and it's got where the two asymptotes would be as well. So I've actually got everything within my sketch. We okay with that, folks?